Welcome to the 7th lecture on the OpenACC course. And we looked at all the different kinds of constructs that are primarily used in OpenACC programs. What we are going to do today is to apply it to certain vector operations. So let's get going. Today we are going to also, in this process, do some sort of a practice, both today as well as tomorrow. And hopefully we'll be able to learn together in this setup. Okay, so let's get going. So there are a large number of vector operations. Essentially what we are talking about vectors are single dimensional arrays, and which are quite prevalent in lots of different applications. Yeah, so today we are going to look at 1D arrays. Tomorrow we'll look at 2D arrays. And many operations like initialization, addition, and then there are lots of other operations that you can perform on vector operations. We are going to look at some of them, but although the functions or the operations are going to be relatively simple, via those we want to learn a few more things about OpenACC behavior and which one is going to be useful in what kind of scenarios, etc. And there are also a couple of new things that we will study in this process. Because as we will see that there are newer and newer facilities that we will require to perform certain operations. Okay, so let's get started. Although we have done some basic vector related aspects in the context of data class, let's start with that. So we did vector initialization yesterday, where we said that A, B, C are vectors, and I wanted to compute C equal to A plus B, and therefore I wanted to initialize A and B also. So one of the ways we did that, right, using the hash pragma ACC data in main, and then there was pragma parallel in the parallel loop inside the initialization function. Right? So this was our code, and although currently it is not showing the data clause, but I can essentially have the data clause also. So this nicely parallelizes the loop, and the vector initialization happens, and all is good, right? Any questions on this basic code? Okay. So one of the natural questions that can come up here is that I don't want to initialize it with these deterministic numbers, x of I equal to 0, 1, 2, 3, 4, like that. I want to initialize it with some random numbers so that I can utilize it in my simulation. It is a very normal requirement. That's okay, I can do that. So what I'll do is, instead of x of I equal to I, I'm going to use x of I equal to the rand function, which is provided in the C library. So stdlib.h is something which I might have to include. And once I do that, then I can simply make use of that. And I want, let's say, numbers between 0 and 99. So I just use mod 100. What do you think will be the output of this code? So I have these arrays A, B, C. I'm initializing only A and then printing the values of A. What do you think will be the output of this code? Okay, so it turns out that this random function is available in stdlib library, but its corresponding dialect is not available in the OpenACC library. Right? So this goes back to our discussion that we were having with Dhrubajyoti, where some of the functions, if these are not present, what happens, and so on. So here the compiler gives an error that this random function is not associated with any accelerator routine information. That means that it is only a CPU function. It's not written for both CPU and GPU. So therefore, we are unable to use this simple random function while initializing or anywhere inside the parallel code. Not only parallel code, but even the sequential code which is running on the accelerator. So there are ways in which we can define our own functions and make sure that those are running on both CPU and GPU. For example, our usual functions which we write, if we don't specify anything and just make use of it, then the compiler will be able to compile that for GPU as well as CPU, so you can run it from anywhere. So that is what we would like to do in this case. If random function is not available, I would like to write my own random function, in the sense that I'll have to write some sort of, let's say, my rand function, which is going to do some processing. Right? That processing could be generation of random numbers via some mechanism. Right? There are ways in which this gets done. Anyway, these are not completely random functions. These are pseudo-random functions. So one possibility is that I can make use of some seed which is provided, and then based on this seed, I apply some function and I store the new value, and that goes on giving me newer and newer or different and different random functions. To the outside world, it appears as random numbers, but actually there is a function which is getting, which is computing these random numbers, and that's why these are called as also pseudo-random numbers. They are not real random numbers. So can I do that? Yes, you can do that. For example, what I'll do is I'll write my own random function which performs some processing. It's not very important what this processing is and why I'm using prime numbers and so on. But let's assume that there is some processing. I mean, there is something called as Mercedes primes which you can use. I mean, there are a large number of different generators of prime numbers, pseudo prime numbers. So you can use any of them. This is just a simple illustration purpose I am using this. However, while that random number generates a random number, it also takes a random number. Right? And how does it work? Well, I have this ACC pragma as before, and inside the loop, I want to send some parameter to this particular function. One possibility is that I can just send I to this, and that will make sure that I get a different value, right? So that is one way in which I can simply get different random numbers across different iterations and therefore across different threads. But a natural choice, I mean, in case you want to, another choice is to use the threads ID, right? So which is going to give us some different value across different threads, right? So therefore, is there a way I can query the thread number in the accelerator code? And there are these APIs that are provided, __PGI_gang IDX and vector IDX. These are going to give you the gang ID and the vector ID of the thread. I'm just summing them up and then applying this myrand function. But otherwise, you can as well write int g equal to ii, and that will give you a unique number, right? In this case, it may not give you a unique number. I mean, g may not be unique across all threads, because gang ID might be 5, vector ID might be 3, and then you can have 5 plus 3 or 3 plus 5 or 4 plus 4 and all those combinations, right? So the function I have used is not really unique. It's just that these are just some random numbers that I'm trying to generate. That's why I'm just cooking up some function. Also to illustrate to you that these are some functions which you can use for identifying the ID of or IDs associated with a thread. Okay. Okay. So any questions so far on this code? All right. So some of the other concerns that come up here is that one question is, how do I find out unique ID of a thread? Right? So for example, there are multiple gangs and there are multiple vector lanes. Right? So the vector ID, let's say 3, if I say, that is not going to be unique across threads. Right? So if there is gang 0, gang 1, gang 2, in each of them there will be vector ID 0, 1, 2, 3 and so on. Right? This is similar to our bus example, where there are multiple buses going from one location to another, and a student's seat number inside the bus is going to be unique for that bus alone. Right? The bus numbers are going to be 1, 2, 3, 4, maybe up to 40 or so. In a similar manner, inside a gang, the vector IDs are going to be same across gangs. And therefore, to find out the unique ID of a student sitting in a bus, what I'll have to do is to find out how many how many students are there in each bus, and then use that along with the gang ID to identify a base to which I can apply this vector IDX, right? Add it. So in the context of our bus example, it's going to be bus number multiplied by number of students in each bus plus the student seat number inside that bus, right? So that is going to be unique for each student across all the buses. This is similar to what happens in the context of our matrices, where I want to identify the unique memory location if I am given I and j as the row number and the column number. So I'll say I into number of columns in each row plus j, and that will give me a unique memory location. In a similar manner, bus ID into number of students inside each bus plus the seat number of the student inside the bus. In a similar manner, what I require here is, so I already have this II and JJ, right? Or I and J in this case. So gang ID is essentially the row number and vector ID is the column number. I just need to know how many vectors or how many threads are there inside each gang. By default, as we saw, the compiler tells that there may be 128 threads per gang and so on, which I can make use of inside my code. But if I want it to be generic, then one possibility is that you can specify the number of vectors inside the gang as a parameter to ACC parallel loop and use that as a computation parameter inside this computation of unique thread ID. We'll see that code also. Nitin is asking something. What if we require to kill a particular thread? How can we achieve this? Is there anything similar to terminate function, or is there some more optimal way to do so? Yeah, just says there is no direct function to do so. On GPUs, all these threads and warps are really executing arbitrarily. If you want some thread to be, I mean, you cannot kill it, but one possibility is that you can take it to execution, take it to completion. So you can have some condition, and based on which, if that condition is true, then you just go to the end of the function or you don't execute it. Right? So that could be one way in which you can simulate it, but there is no way to kill a particular thing.
Going to this question, let's say I have a for loop, okay, which I have parallelized using this ACC parallel loop. Fine. So in between this for loop, let's say if I do something condition, a break, what will this break do?
Okay, so unfortunately, such codes are not allowed, that we cannot arbitrarily enter a loop and we cannot arbitrarily exit the loop. Right? So the parallel loop construct requires that such control constructs are disallowed in the code. At least that's what happens in the PGCC compiler. And I think it was also mentioned in the documentation. So I would imagine that it should be the case in case of GCC implementation.
Okay, so that will not compile at all, is it?
Yeah, it will not compile. Okay. Yeah, and if we have such a requirement, then we'll have to use if else such that the thread doesn't do anything, and for the rest of the iterations, and then comes out of it. Just says we can detect the number of active threads and terminate the idle thread. Yeah, so based on, for example, thread ID, I might be able to, or based on certain condition, I can always write down that condition and say that if this condition is true or if this condition is false, then do something, else don't do anything, right? So this is how we will have to write the code corresponding to this. All right, Good. Okay, so we learned something new, but there is something more which one small part that is required, and that these functions are available inside a header. So we'll have to include openacc.h for these functions to be available, similar to omp.h that we need to include for OpenMP functions, right, to get the thread ID, etc. Okay, so this compiles and runs fine, but one small facility or one small, let's say, issue, I would say in this case, is that I need to pass this as a parameter all the time. That is not a good programming practice. I mean, I would rather want this G to be not there, because the rand function that we use in C library, we don't really pass that parameter. The reason why we had to pass that parameter is because we wanted to provide some seed. Otherwise, if I just use my rand, then that is going to always give me the same value, right? If I cannot have any starting point for my rand. So that starting point is provided by this parameter. Is there a way I can have this starting point, and how does the original rand function do it? The original rand function uses a static variable. So it stores the original seed in that, and then whenever it computes a new random number, it updates this seed. And since it's a static variable inside the function, its lifetime is the whole program, and therefore I can query that next time I enter this function and so on. So that becomes very useful. Alternatively, I can use a global variable so that I update the global variable here and then make use of that while computing. Initialization of G is going to be the first seed, and then I go on updating. So that is one question. The second question we already discussed is, how do I find out the unique thread ID? We discussed this, but I'll just show the code. Okay, so unfortunately, it so happens that the global variables and the static variables are disallowed in the OpenACC kernels. So you can pass these parameters, all that is fine. But since this myrand is going to execute on the GPU also, we cannot have static variables. Static variables are disallowed, and the global variables are also disallowed. And that's a kind of a restriction. So you might have to use some other ways, such as this, where I'm passing this parameter to provide the seed. Okay, or you might want to wrap it. I mean, this myrand of G could be wrapped around and inside some other myrand, and then internally it uses this G. Oh, but we'll have to still store it somewhere. Right?
Yeah, I think we can put it in a class and have a global variable there, right? I mean a static variable.
I don't know if it will be allowed. So even if it is there as a static variable inside a class, that class should be available that class variable should be available on the GPU. If the regular static variables are not allowed on the GPU,
so let's say we have something like a class rand, and inside that we have some static variable, some G0, okay?
Correct.
And right after void init, before doing a pragma ACC parallel loop, we declare an object of that class, and inside that inside the loop we call that object.myrand.
Sure. In fact, since it's a static variable inside the class, we don't even need to instantiate also. We can just say class name : static variable and should still work. But the thing is, it will have to be passed as a parameter. We cannot have it inside this myrand function alone. I mean, it will have to do something from the outside of myrand. That's what I was referring. Yeah, so in case one of you finds a different way in which I can just have very similar to rand function without passing any parameters, and it still gives different numbers, please let me know. I'd be happy to know if it can be done that way. All right, so let's come to this second question. How do I find out the unique thread IDs? Okay, and we know the formula: gang ID into number of threads in a gang plus the thread number inside the gang, which is provided by this vector IDX. So that essentially is going to give me some, this is the formula. The number of threads within a gang, it is by default going to be, let's say, 128 in my implementation, but could be different for your implementation. So it's best, so in such cases, if you want unique thread ID, you don't want to really put this 128 as a hard coding. In contrast, what you can have is, let's say, some variable x, and you specify the vector length, sorry, xx, and you specify that vector length as part of the pragma. Therefore, the control will still be in your hands, and as you change the number of threads per gang, you will still be able to make use of the same computation to find the unique ID. Right? So in this case, this, sorry, I think I should have used probably two different names, x and xx, but this single x is the array which gets initialized with this unique ID 0 to whatever is the value of n minus 1. All right. So this can turn out to be quite handy if you want to just quickly check some codes, and definitely so in our case where we want to perform just vector initialization or vector addition and so on. By the way, any questions so far?
No, in the previous slide, can we compute this global ID in the function itself directly? That we cannot do?
Inside that myRand function?
Right.
Yes, you can do that. The small issue there is that that code will work only on the GPU. So
right. Of course. Okay.
Yeah. So I mean, we can use these APIs in the CPU code also.
Right. Correct.
But just that the values are going to be zeros for this gang ID and vector ID.
Right. Okay.
Yeah, but we can use these functions inside the our auxiliary functions. For example, this myRand. Sure.
Right. That way we can try to avoid that parameter, right? You are.
Yeah, that's a good point. Yeah, is there a way so definitely we can use gang ID and vector ID inside that myRand function. XX. Yeah, so I could not find any API which provides me the number of threads within a gang directly. That's the reason why I had to make use of this. But in case that is also available, then similar to CUDA, we'll be able to compute that unique ID directly inside the auxiliary function. Yeah, that's a good point, Ram. Thanks.
Okay. Yeah, thank you. Please go ahead.
Yeah, thanks. Okay. Okay, so let's move ahead. So now we know how to compute the unique ID. Let's come back to the vectors. So what does this code do? Can somebody quickly tell me? Okay, so this code is supposed to be essentially doing vector addition, right? So this yesterday's code where we had the initialization of A, initialization of A, B, and then I want to add A and B into C, right? So I had these two functions. These are just slightly changed because of I'm now initializing it in a slightly different way, but otherwise the code remains the same as it was before, right? But there is some problem in this code. What is that? Let's recall our learning from earlier classes. There is some problem with this code. Okay, let's see who is the first one to identify the error. Swapnil says C of n. Where? inside main, is it? And why is it an error?
I mean, why are we creating A?
Why are we creating it?
I mean, we could copy in and all that, right? Because we have
Okay.
already instantiated that outside A, B, and C and all that.
Okay.
Also, no point in copying out, I guess.
Okay. Okay.
And apart from all that, in your ad, there must be some sort of a present
Mm-hmm.
and maybe there is something else.
Okay, sure. So that is what we had yesterday for add. We said that the present of A, B, C, which uh, could potentially give additional information to the compiler in case the compiler is not able to figure out that these are already there. But yeah, the suggestions are valid as Rajanya, Durvajyoti, Swapnil, and Ashwati have suggested. Um, why do we need copy out of A, right? A is not really going to be useful after this data clause, right? If at all you would like C to be available because A is not really getting modified on the GPU. Okay? And why also not create B, right? So that is another point. When you want to specify creates, you should be creating, actually, you don't need to really create A and B. What we need to do is to copy in of A and B. So creation is important, that is true. I mean, copy in anyway involves creation. So creation is required, but copying in is also required. And since copying involves creation, we should have create A, B. Should we also create C? Yes, that's what we did yesterday because C is write-only variable on the GPU in the add function. So we should also create C and then copy out of only C should be there. Okay. Swapnil says not initialized under Pragma ACC inside main. C of n, it is actually initialized. I mean, it's not mentioned there. Yeah, the create C is not mentioned there, but otherwise it gets initialized as part of add. So that part should be okay. Okay, okay, sure. Yeah, Shruti also says create and copy out of A are the issues. Yes, so we should fix this. Yeah, so that is what I was asking. So the error that gets seen interestingly, so those parts are there which we can add to the appropriate clauses. But because of this, there is some issue. The issue that happens is that now when we are creating A and copying out A, these are anyway wrong. But because of that, when we are trying to get into uh, this particular C, that C may not be available, sorry, not C, present of X, right? So this present of X is present inside the init function. So as far as A is concerned, this init works fine. But when it comes to B, since we have not really created or copied in B, and we still say that present of B is true, when it tries to access B of II, we get an error. And therefore, we will see this particular error being issued uh, at runtime, right? So the compiler may not be able to figure out that B is unavailable. I mean, B is not copied, etc. on the GPU. So we'll get this error at runtime. Right? So this is one important aspect about the present clause. If you are specifying it, you better be sure that it is actually created or copied in to the GPU. Because as we discussed, the programmer is always considered to be correct. Right? The programmer is the boss. All right. Okay, so this is another part which some common error that comes up when we try to modify the program. So I thought I'll just mention that. So the correct code is what we have seen earlier. What I did now is that can we put everything inside main itself instead of having different functions? What I am going to do is to put everything in main, and there is a reason why I'm doing this. So the create clause is going to require for ABC and copy out of C. So this part is now correct. And then the init part is going to be stored here, but because of this moving everything into main, I can now merge these two loops. Where are the two loops? The two initialization loops. One was for A of I and another for B of I, which were two different calls. And these were turning out to be two different kernels which are going to execute sequentially. Now, when I try to move these things into the same main, I manually look at it and might be able to even merge these two loops and say that A and B might get initialized together. Of course, I should also be able to do it when I have init as a separate function to which I pass A, B as parameters and both of them get initialized. That is also true. It's just that this comes in more naturally now when I see that, oh, there is a same loop, two loops are happening one after the other. Right? Okay, so that is one part. As far as the second assignment to C is concerned, that is as before. Okay, and all of this is inside the same data block. Is this code correct? Any issues with this code? Okay, so nobody seems to find any issues with this code. And it seems to be okay. Yeah, so this code works. One other thing when it comes to when I bring this code here is another thought that might come to your mind, and I'm saying this in the context of vector addition, but in general this thought might come in other programs. Can I perform some operation? Sorry, go ahead.
Yeah, possibly I have a very similar question there. If you want to really initialize in the GPU rather than copying from CPU, sometimes the initialization could be file reading. Typically, data can be read from file in CPU and then copy.
Right.
Whereas here, possibly that facility might not be there.
That is correct.
Reading from file.
Yes. So yeah, so Rama is correct that we'll whenever there are certain functions like fscanf or fread, etc., which are not available on the GPU side, we'll have to resort to that. These operations have to be done on the CPU. You copy the data to certain buffers, pass those buffers, and copy the data from these buffers to the GPU memory. So yeah, that is correct. Right. So the other, yeah, so that is where this question comes up, that can I perform part of the operation on CPU and partly on the GPU might be required. Yes, you can do that. And I would like at this stage people to write, let's say, initialization of A we can do on the CPU and initialization of B on the GPU. Can you write the code corresponding to that quickly? Or at least think about it? Okay, so our previous code of vector addition should work of the initialization, where just that we'll have to make now two functions if at all we are using function-based processing. One is going to be, I mean, both the codes are going to be the similar, both the functions, just that in one function you include the pragma, in the other you don't include the pragma, and then it is guaranteed that that function will work on the CPU where the pragma is at.
Sir, in the initial parts of the courses, you said that this whether running on the GPU or CPU, that actually is important on the compile term. You gave a dash TA multicore or dash TA Kepler or whatever.
Right.
So this, I mean, this sort of a call, if I compile with dash TA, I think that at that point everything will be on the CPU, right?
Yes, exactly.
Yeah.
In fact, many of your codes might just work out if you have this random function, etc., or fscanf, etc. It might just work out if you do TA equal to multicore or something. Right. Okay, sounds good. Yeah, so we'll just do that. So we have this initialization on the CPU, to which I pass, let's say in this case, B, and initialization on the GPU uses the earlier function, and then I can add those together. One thing which I have done here is that I have created A, B, C all on the GPU memory, right? And initialization of A is okay because that is happening directly on the GPU. But initialization of B is happening on the CPU. So that way this B is redundant. Creation of B is redundant. That currently doesn't pose any issues as far as correctness is concerned. However, there will be performance aspects which will come into picture. Thankfully, creation of B doesn't go west, because after this initialization of B on the CPU, we are going to make use of this B on the GPU in the add function. So there will be a copying happening for B anyway, and for which create is going to be helpful. But yeah, if that would not have been the case, then I would have been getting hit by some performance penalty. So we have to be a little careful about that part.
In this, I think we can put init CPU outside of the pragma also, right?
Yes.
Init CPU B.
Yes. So that is what should be happening really, that init CPU B comma N should be actually outside, and then we instead of creating B, we can just do a copy in of B, because B is already initialized on the CPU. That is correct. So create A, C, copy in B, and copy out C. This should be the real one after we move this init CPU outside. Okay. Any other concerns, questions, suggestions here? Okay. So we'll move ahead from here. Oh, by the way, yeah, this is another important point. We talked about these kernels. So there is a possibility, I mean, when we put this init CPU outside, CPU is going to finish its execution and then this pragma is going to be reached. But if this init CPU is part of this pragma, then there is a possibility that the compiler might generate actually no, that will not happen, because the init pragma is okay. No, that is not going to happen. Yeah, sorry, yeah, just ignore this particular part. This is not going to happen. It's going to happen in a different context. In this particular example, it is not going to happen. But if this since this is init is a function which is running on the CPU really, just that the pragma within that is going to be running on the GPU, right? So only that portion, only the pragma portion inside init is going to be running as a kernel. But otherwise, that init function is still on the CPU, right? So that calling of init is still coming from the CPU. So therefore, this is not going to happen. But if there would have been a pragma directly here, let's say, and we use async there, then init CPU can happen in parallel with that hash pragma, right? As we have seen in the kernel's construct. There, the two initializations, initialization of A and B, can actually then happen in parallel on CPU and GPU. Okay. All right. So yeah, which might be helpful in some cases. Right?
But if we do that, shouldn't we put a wait or a barrier after that init CPU B?
So that the GPU add function doesn't start without that?
Yeah.
No, because that add function is also running on the CPU. So, okay, let's see. Okay, so init CPU is going to be over before the add begins, because add function is going to be on the CPU.
Only our add was on GPU, right?
No, so add function per se is going to be using the CPU instructions first. Then it is going to launch the kernel, which is corresponding to the pragma inside that.
Okay. So okay, I get it. So if we had the loop written out directly at that point,
exactly. We have to put... Yes, then we cannot use async.
Or you have to put a barrier.
Or we have to put an explicit barrier, right? Yeah, that is correct. Yeah. Okay, good. That was a good discussion. Okay, so let's move ahead from here. Yeah, but potentially we can get these two initializations happening in parallel, and that can lead to some sort of a heterogeneous computation in your code where you are using two different kinds of devices, in this case CPU and GPU. So, I mean, so far we have used GPU more like an offloader, more like a co-processor, where we said that, okay, there is some operations I'm doing on the CPU. Whenever I require some GPU computation, I just offload it to the GPU, I get the result back and proceed further, right? So that was our usual execution model of OpenACC. But inside OpenACC itself, because of this asynchronous execution between CPU and GPU, you might be able to not only offload the overall work, what you could do is offload part of the work to the GPU, and part of the work can still be done on the CPU, right? Of the same data. Let's say there are 100 elements, and maybe 70 elements are given to GPU, and 30 elements are given to CPU for processing, like that. So that is possible to be done because of such asynchronous processing. So you can get into this heterogeneous programming via such constructs.
I had one thing. This is a bit tangent to this, but let's say because all the clusters, like what we have are in our Inst and all that, nodes are actually having multiple GPUs. So is it possible to have one of the inits run on a particular GPU, the other one on the other GPU? Is it possible? Can we query the GPU, like if there are multiple GPUs in the system?
Yeah, so there is a way in which multi-GPU programming can be done in OpenACC, but I have not studied that, so I really don't know the answer to that.
Okay.
Yeah. So yeah, we have done this multi-GPU programming in the context of CUDA, where we just specify CUDA set device 0, 1, 2. So the devices, I mean, the different GPUs are numbered 0, 1, 2, and you just set CUDA set device 0, and then the rest of the operations, CUDA malloc, CUDA memcopy, etc., happen on that particular device. But in the context of OpenACC, yeah, I don't know. There are definitely functions because I had read it prior to this course, but yeah, I have not really studied it. I have also not experimented.
I suppose there should be some API call, right?
Yes. Yeah. First of all, there will be some APIs, and once we set a particular device, then the rest of the pragmas are directly going to work on that particular device.
I suppose it should be something like pragma ACC, another clause, and in which I can give some of the identifiers. It should be something like that.
That is also possible. Yeah, that is also possible. Yeah. Okay. So yeah, multi-GPU programming is something which is not here. Maybe I should add that next time I offer this course. All right. So that is heterogeneous programming. So let's come to another processing which is common inside vectors. Again, our goal is not really to understand how to compute maximum inside a vector, that we all know. But what are the variations that you can get into, and accordingly there might be some performance changes. So one of the ways is that you run a sequential loop and you just find the maximum, right? So that is one way in which this can be done. And if the data is already on the GPU, you don't want to fetch the data back to the CPU and run this loop. So you can actually run a sequential loop on the GPU just by specifying hash pragma OMP ACC sequential, right? SEQ, and that will run the loop sequentially on the GPU, so that you don't incur the data copying cost. So that part is okay. But like we discussed the other day, max has certain property. What is that property called? Right. So as Rajanya says, it's associativity. That means that if I find, yeah, Ashwati has also says, if I find max of AB and then find max of whatever I had found out along with C, that output is same as max of I find BC and then I find max of A, comma, whatever was max found out, right? So that was our associativity operation. And we said that plus multiplication, all of these are associative operations, whereas minus is not associative. And wherever there is associativity, you might be able to use whenever there is associative operation, you will be able to use something. What is that?
Reduction.
Reduction, right. So that's has been suggested. Suro has also written reduction, right? So we should be able to apply reduction to max also. So let's see what this code does. Right? So as far as maximum function is concerned, there is this parallel loop, and I'm specifying that A is present. By the way, I should mention, so sometimes you might want to specify this explicitly, the starting point colon length of the array, in case the compiler was not able to figure out if it is, and that can happen if you have, let's say, malloc arrays and so on, or if you have arrays where the parameter is coming from runtime and not compile time constant. In that case, the compiler may not be able to figure out how many elements to copy, and it will also not give you any. So if I have this present A, or create A, or copy in A, or copy out A, it might not give any indication. I mean, it does give indication, but it might not give any error or warning. What it will say is that it has copied. Right? And then if you look at the compiler output carefully with -m info, you will realize that it has actually copied one element of that array. It might not copy all the elements because it doesn't know how many elements exist. Right? So we have to be careful about this particular aspect. So if you want to be in general careful and want to specify 0:n, just do that all the time. Okay. What does it do? It just assigns maxima as a local variable to a of 0, and then from 1 to n-1, it checks whether maxima needs to be updated and returns that variable. Inside main, I have this data create of A. I initialize it using some initialization function, maybe some random values. And then I call this maximum function and store it inside this maxima variable, which is local to main. Yeah, by passing A as a parameter. And then finally, I print the array as well as the max that is obtained. Right? Does anybody see any issues with this code? Okay, we don't need copy out of A in this case because A is not getting actually we will need copy out of A because we are printing the value of A here. I mean the whole array. Since it gets initialized on the GPU, yeah, we'll need copy out of A also. Yeah, that is one thing. But is there any other issue with this code? Okay, so it turns out that it starts printing garbage, right? And that is because of this copy out of A being not present. But any other things? It also doesn't print the max value correctly, because so that copy out comes into picture only at the end. But as far as the GPU processing is concerned, it should still be doing it on the GPU memory where A is available, and therefore I should be able to get this maxima properly. Unfortunately, it doesn't get copied from maximum to maxima, and I really don't know exactly why this is happening. Is it that because we have to specify copy out of maxima and so on here? I really don't know. But this code, because of that, I mean, we know the reason why it prints garbage for A, but it doesn't print the value correctly for maxima also. Okay, and it has nothing to do with reduction. As far as this code is concerned, it may not. I mean, this code has similar behavior even if we add reduction, right? So that is what I wanted to convey here. What works is, I'll tell you the modified code which works out. So the maxima finding code remains the same, but when I move this printf inside, then the maximum value is rightly printed. This has some indication that that copy out of maxima might have worked in the previous case, but I think I have not tried it out. I just realized it now. But copy out of A fixes this issue with respect to print. I think I should have tried copy out of maxima also, and maybe the previous code would have worked according to that, right? So the reason behind specifying this is not really to get into focus on max as such, but this part where there is automatic copying may happen, may not happen, this can cause issues in the context of reasonably large OpenACC programs. And sometimes you might not be able to even find that such a thing is happening unless you actually go through the compiler output very carefully to figure out what exactly is getting copied and what is not. And even some of my students in a course where I taught OpenACC, they faced a lot of issues because of this automatic copying that may not be happening, and they were not able to exactly figure out why that may. I mean, there is a logical reason. It's just that you have to look at it. You have to be aware that this is happening, and the compiler unfortunately does not give any indication. For example, here the compiler could have possibly told me that copy out of A should have been done because there is writing to A happening here and printing of A happening after that on the CPU. But unfortunately, the compiler doesn't say so, and therefore we as programmers have to be aware of this and take care of this. Okay. Yeah, so this part I think should be okay. So this code works, right? And this code prints the values correctly for A as well as the max also correctly for the array. Okay, so another small example which I would give is now in the context of kernels. So what I have done now is that I had this nice data clause. Instead of that, I go back to our magical keyword of kernels, where I specify that, okay, there is some initialization, there is some maximum happening, and I'm printing something. Go figure out which one you want to parallelize and let the compiler do its job. Right? So what do you think is the output? Please spend time thinking about this code and tell me what will be the output.
Sir, one thing. In this example, in this init function which you have written, does that have the pragmas or is it a normal init?
Yeah, it has a pragma. Why do you ask?
No, I was just being sure. Like since this is a kernel, so.
Oh, I see. Okay. Okay, I will have to check then. Let me just quickly check right away. No, I didn't have any pragmas. Yes, you are right. So since this is kernels, I should not have any pragmas. Yeah. So I didn't have any pragmas in the code for init. Correct. In any of these functions. Okay, so it so happens that when I run and compile this, when I compile and run this program, I actually get a wrong output, right? So recall that we were getting the correct output when I had the data clause added correctly, but when I do the kernels, I don't get the output correctly if I put this inside the kernels. However, if I move the maximum function code here inside the kernel's pragma, then it starts printing the correct output. Okay, so let's analyze. So this code is exactly same as what we had inside that function maximum. Right? So let me go back and show you the code again. And can somebody suggest why this is probably not working correctly in the context of kernels?
Yeah, I guess it is not able to understand the dependency between the A has to be copied to maximum. The finally, the GPU result is there in the GPU that has to be copied into the CPU variable maxima.
Mm-hmm.
Possibly it is not able to understand the dependency.
Sure.
Maybe because it is not understanding where it has to place a reduction or something.
Where it has to place the?
So this max needs a reduction, right?
Uh-huh.
So kernels is not about.
Okay. Right. So the idea behind highlighting this code is that again, that when we write sequential, I mean, the way we write OpenACC programs is we start with sequential code, and then we start adding these pragmas. And one of the first things that we usually try is this kernels, where okay, go figure out what needs to be done, etc. And that might not work out, especially if you have these uh, multiple functions which might span uh, uh, various dependencies of variables. So this is kind of the takeaway that even my students have found this out, that if you put everything inside main, things suddenly magically start working. But if you have these functions, then not always the compiler is able to do a good job. Sometimes it does, but not always. So therefore, we have to be a little careful about this part until the compilers mature to handling of arbitrary function calls and recursions and whatnot. So that's another reason why you should not get surprises that I'm mentioning this example. And you will encounter this because typically we will have all these function calls as part of main. And then internally those are going to get, I mean, by default going to get parallelized. So if you use ACC kernels, we have to be careful. If you use pragmas, then we have to be worrying about the copy in, copy out costs. But as soon as you add data clause, then since the programmer is always assumed to be correct, if you miss out on something, then we have to pay the cost, right? And the compiler might not tell you very emphatically. It will tell you what is happening, but you will have to go interpret. Okay, so this is yeah, this is kind of what I wanted to convey. There are a few homework exercises which I would like to specify. So in case of max, although we did not use explicitly reduction, but that reduction does happen and automatically when the compiler is able to figure out with respect to certain constructs. If you write a very arbitrary piece of code, you can fool the compiler, and then the compiler might not be able to figure out that it should be using a particular operation for reduction. But by and large, it is intelligent enough to understand multiple syntactic ways in which we write these max. For example, I use this if clause and so on. In a similar manner, you might want to, yeah, so when compiler is not able to figure out, you might have to specify that, and you should definitely try out for different examples. In some of the limited cases, you might be able to use atomics instead of reductions, which might use some hardware supported intrinsics, and that might turn out to be faster, even more than reductions. So that you should try out. But some of the other examples that I would like you to try is, let's say you are given two vectors and you want to take a union of all the elements inside those. So treating this vector as a set. Some of these operations may not be very parallel, but these will give you enough, let's say, hands-on experience with using vectors as well as different clauses that you will get into problems, and while coming out of those problems, you will learn. Some of the other operations, again, this is not very parallel, but merging two sorted vectors or arrays is something which we do regularly in the context of CPUs. You might want to try doing that on the GPU and see what happens. And again, the surprises will probably teach you. And you can generalize it for merging k-sorted vectors instead of two. And next step will probably be making this k um, input dependent. Input dependent meaning it's not known to the compiler what this key is. Can you still make sure that your code is working correctly? Right? And then using two arrays, two vectors as key value pairs, can you sort these associative vectors, right? So you have, let's say, roll numbers and marks, right? And you want to sort in two different vectors. You want to sort according to roll numbers, or you want to sort according to the marks. And I mean, when you change the roll number entry, then the corresponding marks entry should also get modified and so on. So that's a key value pair which should be updated as you saw. So there are a large number of parallel algorithms in the context of sorting, but our usual algorithms like quicksort or shell sort, which are more common in the context of CPUs, are not the most efficient ones on the GPUs. So there are other like radix sort or even merge sort might turn out to be reasonable in the context of GPUs, but merge sort is not that used. For the partitioning, it is useful, but merging involves again sorting of, merging of two sorted vectors, which has some sequential cost involved. So you can try out, although some of the simple ones like the bubble sort and selection sort, etc. Those you can definitely try out and just see for your example, for your benefit, how it is working and what the performance is. All right, so this is what I wanted to cover with respect to the vectors. Tomorrow we'll do certain operations on matrices in a similar manner as vectors, but hopefully we'll get into more problems as we get into slightly larger programs like matrices. And we'll do that tomorrow. Yeah, I'll wait for any questions now. Okay, so the number of questions seems to be reducing over days. But anyway, that's fine. I'll wait for one more minute. I'll stop the recording now in case there are questions.